Hi everyone, I'm Amir Hossein. In this video I will show you how to run RTTOV model using RTTOV-PI software and WRF model output to simulate MSG SEVIRI data. MSG SEVIRI is a MSG satellite. MSG or Meteosat satellite is a geostationary satellite. So for a geostationary satellite, the position of the satellite is quite different from the LEO satellite. I will show you how you can handle it by the RTTOV-PI software. So you know that RTTOV-PI is available on GitHub. You clone it on your local machine here, then navigate to the WRF data directory, open name list, and you already know the directive here. You set it according to the previous videos I prepared. I don't want to just explain them again, but just let me show you that this coefficient, this is related to SEVIRI satellite. So you can show what wavelengths are inside this coefficient. RTTOV wavelength. This is a flag you can use to show the bands that are inside that are supported by coefficient. So we have 12 bands here, and these are the wavelengths from visible band to the thermal bands. Okay, let's get back. This is time of simulation. I will not change it, and you are already familiar with the directory suffix and output data directory. You can change, or if you like, you can change them, or just you can use it as they are. MSG underscore input is a suitable name for the input and output directories. And for the WRF chem dust profiles, this is the block that you can use to simulate radiative transfer, which is affected by the dust particles. In this case, I will skip it, and I will keep it as false or disabled, and in the next video I will get back to it. For the satellite information, the important point, as I mentioned, we want to simulate an image of Meteosat satellite, Meteosat SEVIRI sensor. So the satellite name is 23. What does it mean if I open satellite name? 23 is 23. Meteosat 9 is the name of the satellite here. Satellite channels, we want to simulate 3 channels on this time simulation, and these are the name of these 3 band names. You can see that they are in the thermal band. The wavelength is 8.7, 10.8, and 12. And this user-defined position, this does not apply to this case, because a geostationary satellite, it has a fixed position. So this does not apply, and it doesn't matter if you change it or enable it or disable it or modify it, does not apply. Also the historical TLE, we just leave it as disabled. And for the post-processing and verification, I will get back to the post-processing and verification. So for geostationary data, the only data you need to set is the satellite name index, satellite channel list, and satellite channel names. User-defined, the position does not case for a geostationary satellite, because they can be internally calculated by the RTTOV-PI software, so you don't need to care about it. I save it and I run it. Before that, the post-processing was enabled. I should disable it. False. Otherwise it tries to find out the post-processing directory. Right, so you can see that the input data are generated here. Now we have the input data here in this directory, and we also have this shell script that can run RTTOV model using these input data. So it runs RTTOV model on each of WRF grid points. Okay, so now I run it G-Fortran. I run the shell script. It runs the RTTOV model on each grid point using the generated input data. Okay, the input data, the generated output data, RTTOV output, they have been finished, and now the outputs are available here. These are the outputs, and now we want to before that, let me show you one of them. And this is the output of the RTTOV model, and for the first grid point, and here you can see that calculated brightness, temperature, satellite reflectance, radiance, and other radiative transfer variables are available for this specific grid point with the specific atmospheric input data. Now let's get back to name list for post-processing. I enable post-processing here. This is the suffix for the post-processing directory, and image plot all bands, make it true because it makes an image for all the netcdf data. And the RGB plot, it does not apply here, so just set it false. Save it and run the model again. Run RTTOV-Pi again. Actually, RTTOV-Pi is not a model, it's a software, or it's a tool. Okay, after running RTTOV-Pi, you can see a new directory here, post-processing, and post-processing. Let's say I open Radiance NC, and the three bands that you specified in the name list here, you can see the outputs of the RTTOV-Pi on the WRF domain. So this is the RTTOV output, RTTOV output simulation that is mapped on the WRF domain. And also there are some images here. You can see the brightness temperature for different wavelengths, emissivity, overcast radiance, transmittance, and again brightness temperature. These are also available here, but of course you can use the netcdf data to if you need more analysis, you can do whatever analysis you like on these netcdf data, which are actually the output of the RTTOV model. Okay, let me get back to name list for the verification. This is the verification section. What does verification mean? Verification is that we want to compare those netcdf data of the RTTOV output file with the observational MSG SEVIRI data. So we have previously prepared MSG SEVIRI observational data. Where are they? You can see here the satellite file groups is true, so this directive is skipped. If this group file is true, the satellite file directory here, it will be considered. let me go to the or list the content of this directory. You can see that one satellite MSG SEVIRI data is available here, and this is exactly the time of this satellite is exactly the same time of the simulation. You can see 22, the month of 5, day is 16, and hour is 12. The same specification is here. So this is the right satellite observation data to compare the RTTOV output with the WRF model output. So we set it true, the verification of the name list, we set it true. This is the suffix, you can change it if you like. Satellite file path is skipped because satellite file group is activated, and satellite sensor ID is very important. Satellite sensor ID, satellite sensor ID. This is SEVIRI sensor ID 53 MSG Meteosat 8 to 11 SEVIRI data in native format. So this is the right selection for the sensor that we want to use for the native. And if you see it, if you take notes, this is the native format, and here we can see that the format of the file is native, so that was the correct choice. And Taylor diagram, this is the name of the Taylor diagram. And keep remapped satellite to WRF data. This is also, this can be useful information if you want to map your RTTOV output on the WRF domain. You can check it, you can set it true and enable it, and this is the name of the remapped file name. Okay, just save it, and before that I changed the Python environment to support all the required libraries. Then I open it, then I run it, Python RTTOV Py. There are some warnings, you can just skip them. Band 8.7, band 10.8, and band 12. Okay, now there is a new directory, verification. Go to verification, and here if I open one of these netcdf data, let's say, yeah, this is the mapped MSG data. We actually mapped the MSG satellite data on our WRF domain. There was no analysis in this case, we just mapped the MSG data from the original observational data on the WRF domain. However, there are verifications here. This is the verification, the Taylor diagram. This is the Taylor diagram. You can see that for these three bands or three channels, this is the situation of the statistics of the Taylor diagram. And also you can see the exact scores of a statistical analysis or the parameters of the Taylor diagram here for extra analysis you can use these scores.